Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 62, and we're told that we have this molecule called GBL with the molecular formula of C4H6O2. This is an IR spectra at 1770, which corresponds to a carbonyl group. And we have actually some HNMR data. We have a multiplet at 2.2 for 2 protons, a triplet at 2.48 for 2 protons, a triplet for 2 protons at 4.35, and that's just determine the structure of GBL. So just like before, the first thing we need to do is determine the degree of unsaturation and number of double bonds or rings. So number of double bonds, degree of unsaturation, or the number of rings equals number of carbons, being 4, minus number of hydrogen halides over 2, so it's 6 over 2, minus number of nitrogens over 2, so that's 0 over 2 plus 1. So we have 4 minus 3 equals 1 plus 1 equals 2. So we have 2 degrees of unsaturation, and we have a carbonyl group. So right off the bat, let's draw that carbonyl group here. And now let's see what else we have. Well, we have 2 triplets that are representing 2 hydrogens. So we can say that we have these 2 hydrogens are neighboring these 2 hydrogens, and therefore they're going to make triplets for one another, just like what's seen. How many more carbons do we have? So we have 1, 2, 3 carbons, so we have 1 more carbon. So if I were to just draw that 1 carbon here, we can say that, okay, well, this carbon is also going to have 2 protons. And now I ran out of protons and I ran out of carbons, but I still have 1 more oxygen and I have 1 more degree of unsaturation to fulfill. So because of that, the only way I can fulfill a degree of unsaturation without adding any more carbons or hydrogens is to make a ring structure. So if I were to connect this carbonyl group to here, and then I were to connect, instead of having a carbon, I can use one of my oxygens to connect this group here. Now I made a reciprocal structure, which uses 1 degree of unsaturation. I have a carbonyl group, which uses 1 degree of saturation. So those 2 degrees of unsaturations are satisfied. These 2 protons are neighboring nothing on the right, but 2 protons on the left. So these would be a triplet. These 2 protons down here are neighboring nothing on the right, but 2 on the left. So these would also be a triplet. And the proton in the middle are neighboring 2 and 2. So this would act as a multiplet because we have the m plus 1 times n plus 1. So in essence, we would have up to 9 peaks for these 2 protons. So this would actually satisfy all the data that's given, and this is a proposed structure for GBL.